Good morning, Year 12 single mathematicians. Just going to go through a request from the pure paper one, the practice paper I put on Teams. It's question 14. It's to do with a circle, and the first thing you have to do is find the centre and radius of that circle. So what I'm going to do is group together the x's, group together the y's, and use completing the square. So put the x's next door to each other, put the y's next door to each other, leave the number by itself on the end. I'm going to complete the square on this, and I would go to x minus 3 squared, but you've got to remember to subtract 9. This would go to y plus 5 squared, but you've got to remember to subtract 25, and then you've got a plus 9 on the end. So I've done those separately, and then if you take the numbers to the right hand side, you get this is equal to 25, and then you can state the centre, which would be whatever makes these brackets 0, so 3 and minus 5, and you can state the radius, which is the square root of the number on the right hand side, which is 5, and that would be part A done. Part B then gives you a line kx, where k is a constant, and it cuts this circle at 2 distinct points. So this circle, if we drew a very quick sketch of it, say that's 3, say that's negative 5, and it is a circle, so it's going to look something like that. Okay, and this kx is just some straight line which goes through the origin, and we need to find the values of k for which it cuts this circle at 2 different points. So for example, negative gradient would work, and maybe a really big positive gradient would work, but there are obviously some values which don't intersect at all. So if I was going to do this, I would try and solve it algebraically, and I would always use, if I've got 2 things which intersect each other, substitution. So part B, use substitution, replace every single y in the original equation with kx. So replace every single y with kx, so call that equation 1, call that equation 2, substitute 2 into 1, and you get kx squared plus y squared, subtract 6 kx plus 10, 6x plus 10 kx plus 9 is equal to 0. And then expand everything out, k squared, x squared, that should have been an x squared, sorry, k squared, x squared, plus x squared, subtract 6x, plus 10kx, plus 9 is equal to 0. Collect the like terms. It's not easy to collect the like terms, so you're going to have to use factorising. So take an x squared out, and you get k squared plus 1. Take an x out, and you get 10k subtract 6, and just a plus 9 on the end. And remember, this quadratic, with these weird coefficients, it needs to have 2 solutions, because it needs to intersect at 2 different points. And when you talk about the number of solutions, the first thing that should come into your head is maybe I need to use the discriminant. So the discriminant would be b squared minus 4ac needs to be greater than 0. And if you substitute b in, and you substitute A and C in. See what you would get. You'd get 100k squared subtract 120k plus 36 subtract 36k squared subtract 36 is equal to 0, to give you 64k squared subtract 120k. Well, the 36's cancel, so that's just equal to 0. And then you can factorize, do the simple factorizing, take a k out to give you two different answers. K is equal to 120 divided by 64, which is 15/8. I've just realised I didn't really explain what I was doing there. So the discriminant is greater than 0, so these should have been greater thans, not equal to's, greater than, like so. And when you want to solve a quadratic inequality, you have to draw a sketch of the quadratic. So the sketch would be a shape, positive quadratic. The second thing would be the y-intercept, which is when x is 0, or in this case k is 0, and that would give you y is 0. And then the third thing is the x-intercepts, or in this case the k-intercepts, and that would be what I've just done there. So I worked out where it would cross the x-axis or the k-axis, and when I draw all of that information, I get 0, 15/8, and a positive quadratic, like so. I want the answer to be greater than 0, which means I need this, and I need this. So either k is less than 0, or k is greater than 15/8, and that would be it.